Hello, welcome to this video introduction to probability. Probability is not determinism. Determinism would be knowing exactly when, how something would occur. However, there is so much variability that we can't possibly account for that in any sort of statistical model or prediction. Nonetheless, probability can allow us to predict, and it can give us an understanding of a realm of expectations. In order to calculate probability, you can use your z-score to identify an area under the distribution. So that area is represented as a percent. This is 68% of an area, say, for example, from a certain score to the left-hand side of the tail of the distribution. So we take our 68% divided by 100%. Can cancel off the percents. That leaves us with 68 over 100. If we divide 68 by 100, we get 0.68, which is probability. Now this can look extremely simplistic in the sense that really, aren't we just dropping the percent sign and moving the decimal place 2 places to the left? Well, mathematically that is what we're doing. But the point here is that an area under a distribution can serve as a probability of a score falling within that area. So let's say, for example, that our area represents 68% of the distribution. There is a 0.68 probability that any given score point will fall within that area of the distribution. So, in other words, the area of a normal curve distribution and the probability of a point falling within that area are obviously related very directly. We'll talk about statistical probability in a minute, but empirical probability would be in sort of a study environment. If you were to count the number of occurrences of something and divided that by the number of possible occurrences, you would get what's called the empirical probability. Let's say, for example, that I sat on a playground, not in any sort of creepy way, but we're watching students play. Let's say that I was watching the number of occurrences that students would play jump rope. I would count the total number of students playing outside with a jump rope and divide that by the total number of students playing outside, period. And that would give me a probability that any given student would be playing with jump rope. When we talk about statistical probability, however, we're really framing it as a function of the normal curve and what are called exclusion areas. If you think about our normal curve with a mean of 0 and 3 standard deviations above the mean and 3 standard deviations below the mean, we know that almost all points in the distribution fall somewhere within plus and minus 3 standard deviation units. However, we also know that at a z-score of negative 1.96, the area under that or to the left of that z-score is only about 2.5% of the entire distribution. Similarly, at a score point of a z-score of 1.96, the area to the right of that point is only 2.5% of the total distribution. These are what are called the exclusion areas. In statistics, we generally say that any point beyond plus or minus 1.96 z-score would represent an exclusion area. It's an area where it's unlikely that a score point would fall due purely to chance because these exclusion areas only account for 5% of the total distribution. So you may have heard the term statistical significance. And essentially, generally speaking, statistical significance means that a score point is not likely to fall within the exclusion area. There's a very small chance, only 5% chance, that it could fall into an exclusion area. So generally, if an occurrence has less than 5% chance of falling into the exclusion area, we think that it's less than 5% chance of being due to chance. It is more likely due to some sort of significant factor in the data. So these exclusion areas are going to be very important in our upcoming learning because they're going to be very tied to what we call statistical significance. And that's going to be important for making meaning out of our data. And we'll be learning much, much more about this in the coming weeks. This was just a short introduction to it. As always, if you have any questions, please let me know. Thank you.